So the pump itself has to suck the material up in the suction hose. This valve here is what we call a dump valve or relief valve. What that enables us to do is to exit or exhaust the pressure from within this pressure chamber to enable two things. One, to prime the pump, and two, to ensure that if there is a block in the line or the gun, we can exit or exhaust the material within this chamber through another means, not only the gun, but through this tube as well. Also too, when you first start to use this pump, we open this valve, then we put air over the air motor to get actuation of the pump itself. The fluid should travel through this to ensure we have free flow of fluid from the pump and exhausting out here. It's important that you make sure fluid does exit out through this tube. A small tin like this is appropriate to ensure that that does happen. So what we'll do now is we have solvent, we have a connection, we have the dump valve open. So with the air on the back of the pump with the valve open, I will now put air into the air motor to get an actuation of the pump, and with this open it should exhaust out through this line here. Now you notice I stopped the pump. The main reason I stopped the pump and didn't keep it pumping until material came out of here, the chevron packings that are in this pump will only sustain 15 to 20 seconds of free flow of pump. What I mean by that is if the pump continues to pump and there's nothing in there for it to suck up, the packings in the pump, which I'll show you further in this DVD, will actually umbrella or cook because they sustain or generate a fair bit of heat within this small chamber. So again, I'll actuate the air over the air motor. So I have no fluid. What could be wrong? I'll give it one more try with short bursts over the air motor to ensure that the fluid does come out. So obviously there's something wrong with the pump, it's not sucking. Do I have enough fluid there? Yes, I do. Did I make sure that was tight? Let's check it again. Yes, it's tight. With the valve open, air on. Okay, there's no fluid exiting from this tube. Therefore, I have a problem with the pump. What could it be? Could I have sucked some rubbish up out of the material? No, the solvent was clean. Is there a break in the airline? On the suction hose, I should say? No, there's not. Is that tight? Yes. Is this section of the pump tight? Yes. So now what we need to do is, because we didn't pick up any solvent, we need to check this primary valve in the bottom of the pump, what we call the foot valve. So we've got two valves in here, primary, which is at the bottom of the pump, and secondary, which is the end of this piston. On the lower end of the piston, there's a secondary valve. So there's no point in me putting that back in there, turning that on, and continue to pump, and free pump without any fluid, because as you saw the piston jumping up and down, that's a good sign. When you get the piston chattering in its motion with very little solvent in there, that's a good sign, because primarily that tells you that the packings are in good repair. So the packings are tight on the piston is working the way it should. The only lubrication that pump gets is from the fluid that you put in there, be it paint or solvent. Now you won't get much lubrication out of solvent, primarily because it is a cutting agent. So the only lubrication I will actually get out of that to reduce that chattering of the piston will be the fluid or the material itself, which is paint. So now what we'll do is we'll take this out of the way. We will release this suction hose with the air turned off. So it doesn't matter if someone turns this, tries to operate it, the machine is now null and void as far as operation is concerned. In paramount importance that you isolate that section. So my assistant will now turn the air off to the pump to ensure that I cannot get hurt. So once he's isolated the air, the important thing for me to do is with the small amount of air that could be in that air hose has to be exhausted somewhere. So once he turns that valve off, I will now exhaust this line through the three-way valve. So the three-way valve on the back, it's on or it's off. And in the middle is an exhaust. So it's now exhausting out through the three-way valve, which turns the air, gives air to the air motor. So while it's exhausting, I know that there's still air in that line. Is this tight? Yes, it is. So it's unsafe to do anything to this pump until that's completely exhausted. Now, as you can hear, the air is now expelling from the unit, and look at this inch hose. I can now squash it. So with 100 psi in that hose, there's no way I can physically squash the hose like so. Now we check the regulator. No, there's nothing there. That's deemed safe now to operate on that pump. How else could I make it safe? Go back to the compressor and isolate the compressor to ensure that nobody can turn the air on whilst I'm operating this pump. The other indicator I'll have is I'll leave that three-way valve in an exhaust mode. It's primarily, if someone does turn the air on, I can hear it exhausting out the other section. So, now that we've isolated the pump,